Hello, everyone. Welcome to this joint webinar between Redgate and JPA Buddy on the database migration challenges with Java apps, which we'll be dealing with JPA Buddy and Flyway today. My name is Barry. I am part of the Flyway team here at Redgate. I'll be here fielding questions on Flyway migrations, and I'll pass on to Andre.
Hi, everyone. My name is Andre. I'm a developer advocate for JPA Buddy, which is, my presentation doesn't work. There we go. Which is a plugin for IntelliJ IDEA that makes working with JPA and related technologies easier. Basically, it provides a lot of code generation and visual designers for things like JPA entities, Spring Data repositories, Flyway migration, Liquibase changelogs, etc. So makes the developer's life easier. And today we'll discuss various database migration challenges that Java developers face and how to combat them. In general, evolving your database is not a hard task. It's not rocket science. Sometimes it's even trivial, like any junior developer can write a migration script, right? But there are still things where even experienced developers struggle in some corner cases, and there is still room to simplify this process even further, although having a tool like Flyway obviously makes it much better. Yeah. So to make things easier to follow, we'll be going through an example project. To mention, your company decided to branch out its business, and they wanted to make a blogging platform where authors will publish technical articles. Basically like DZone, but better somehow. And they go to you to ask you to develop it. So you come up with the following database schema. You have 3 entities in your MVP: your article, comment, and author. Now it's time to start the development, but which approach do you take? Basically, there are 2 options. The DB first approach, where you create the table, then the corresponding JPA entity, and the JPA first approach, where you first create the entity and then the table for it. The main difference is in where the source of truth lies, in your database or in your Java code. We've run a poll on Twitter, and basically it turns out the division is almost 50-50. People use both ways. There are advantages and disadvantages to each of them, but that's a topic for a separate talk. I'm not going to get into it. But me being a Java developer, I prefer the JPA first approach. So that's what I'm going to start with. Actually, I've prepared a project with 2 of our 3 entities, article and author, already prepared with all the attributes. Author has like name, date of birth, link to articles, and article has permalink, title, text, and the back reference to authors. Now, I have also created a database. The problem is it's empty, and I have to create the tables in it. Basically, I have all the information necessary here in my JPA entities, and I have to write the same thing a second time, but in SQL. And this is actually the first challenge that we're going to talk about, which is keeping your JPA entities and DB tables in sync. Now, why is this a challenge? Well, as I already said, you have to write the same thing twice in the JPA model and the migration script, which means that it's easy to miss something or make typos or errors because, well, we're all people, we all make mistakes, and obviously takes time and costs money. The solution, code generation. You remove the human factor and you save time. Let me show you how it works. JPA Buddy actually provides a tool for this. It can generate database migrations based on the difference between your JPA model and your database. All you have to do is select New, Flyway, do version migration. You can configure a source and a target. We're going to compare model to the database. You select the database connection, click OK, and you get a preview of the script that's going to be generated. Since our database is empty, this is basically an initialization script for our model. Let's call it just that, model init. OK. And let's run it. To run the migrations, I'm going to use the Flyway Maven plugin. So all I have to do is run this Flyway migrate go. I've configured everything in advance. So yeah, it should work. And we should see our tables appear here. Once it loads, there we go. Yes. We have all the needed tables. Right now, they're empty. Now, as I said, there are two approaches, JPA first and the DB first approach. If I was to take the DB first approach, I would face the same problem. For example, let's create a third entity, which is comment. I'm going to create a new empty virtual migration. Call it just that, comment entity. OK. And I've actually prepared a script for it in advance. Let me find it. I'm just going to copy and paste it. There we go, and run the migration. So let's check our database. There we go. And again, we have the same problem. Our data model and our database are not in sync. And again, code generation is what can help us, but this time not script generation, but reverse engineering, which is also something that JPA Buddy provides. I just need to right click on the table, comment, pick entity from DB. Here you can configure the name, etc. We're going to leave it as is. Click OK. We get the preview of all the attributes that JPA Buddy detected. We have one column text, and we have two references to article and author, which are going to be mapped as many-to-one associations. Click OK. You get the whole entity, and that's it. Well, let's imagine that we launch our application as it is, maybe internally, and our colleagues start to write first articles, leaving first comments. And to emulate this, I'm going to just create a migration with some test data. I'll go with that. Test data. OK. I've prepared it in advance as well. Just copying it, pasting it. And let's run it. So now it's almost as if we are working with an actual application that has some data. So let's check that. Yeah, in the article table, we have two records, two articles. Anyway, as our application is used by people, we decide to make some changes to it, some improvements. So we change the data model. First, we decide to make the title of the article not nullable. For example, at first we wanted to keep it more casual, maybe use some first words of the article as the title, but that's not good of an idea, so we decided to make it not nullable. Then we want to add the publication date to our article, and we want to delete the date of birth for our authors, maybe for some legal reasons or something like that. No. So the thing to remember is that we need to make three changes. Make title not null, add publication date, and delete the date of birth, just not to store maybe some personal information. Let's do just that from the JPA side. We make the title not nullable. Actually, JPA Buddy provides a JPA Inspector panel, which lets you edit existing entities. So all we need to do is click one box, and as you can see, nullable false appeared. Now, we also wanted to add a publication date. There is a separate panel for generating things. We need an attribute of basic type. For type, we'll use local date, and we'll name it publication date. Okay. And we also wanted to delete the date of birth from our author. Getters and setters. All right. Now, if we generate our migration script, we'll see that, let me do that. We'll see that the changes are color-coded. We have green changes, red changes, and yellow changes. And that's because some changes are safer than others. We have our green changes, which are basically safe to run. You don't have to think too much about them. And that's your add column, create table, etc. Changes that don't deal with existing data and can't basically cause any data loss or something. Then there are changes that can obviously lead to data loss, which are drops. Drops are a problem because they aren't easy to revert. If you drop something, you can't just undrop it easily. You have to either create a backup of your database before each migration, which is a good practice in general, but you can never be sure that the update is up to date always. Someone can jump in at the last second, change something in the data, add a new article, add a new comment, etc. And that data might be lost if you recover from the backup. Another thing you might implement is drop policies. An example would be not dropping anything and just renaming it. For example, if we want to drop date of birth, we don't do it. We just rename it to date of birth _ unused or something similar. This has its own set of problems because right now in our data model schema, date of birth is not nullable. And if we simply mark it as unused, we won't be able to add any new records to the table without specifying a value for this unused field. So yeah, just something to keep in mind. If you are to implement any drop policies, always think about constraints that you need to remove to allow for that. And then there is a third category of changes, which is changes that are generally safe, but can make your migration process fail to run. And adding not-null constraints is an example of such change. If we actually save the script right now and try to migrate, we will get an error saying that column title of relation article contains null values. If we open our database view, we'll see that we have an article with null title. So how do you deal with that? Well, first let me remove that script as it obviously doesn't work. Generate a new one. Now, for adding not-null constraint, there is the best way I think you can deal with it, and there is the one that also works, but I don't like it much. The best way is to add a default value, which will be used to replace all the null values in your database. For example, we can use something like unknown title. Right? So now this change is guaranteed to run successfully, because basically we won't have any null values after this line. So we should be able to add the constraint successfully. Now, let's name this script something like model update. I know it's not too descriptive, but it should work now for now. Click OK. And if we run this migration, it completes successfully. And if we go to our article table, we'll see that the title of the second article was changed to unknown title. Now, there is also a second way to combat this issue, which is deferred validations. Deferred validations is when you apply validations only to new entities and all of your old records remain intact as is. In Oracle, it would look something like this. You will just write enable null validate, and then that's it. Your constraint is going to only be applied to new records. But only few RDBMS is supported. Postgres doesn't, and I use Postgres. And there is a similar feature here, but it doesn't work for not null constraints, for example. And moreover, even if you use Oracle, imagine adding this constraint, you still can't be sure that when you fetch that data from the database, that this particular attribute is going to be set, that it's not going to be null, because it could be an old record that was created before you added this constraint, and then, well, you have to basically have to check for null each time anyway. So why add the constraint in the first place? So yeah, I think the best way to combat this is to actually provide a default value. This was actually the second challenge, which is that some migration can cause loss of data. And to sum up, there are three types of migrations. There are safe migrations, add column, create table, etc. Migrations that can cause data loss, which are drops, and migrations that just might fail to execute. Add not null constraint is one of them. We walked through possible solutions. And actually this applies to adding constraints in general, because if you have any data that does not comply with the new constraints, well, you can't add it. It will fail. So yeah, again, you can use deferred validations, or you can actually check the data beforehand, which, well, might be more suitable in some cases. You just have to remember to check it on the broad database and not your local database. Otherwise, there's no point. Anyway, imagine that we use this application that we've been developing for a couple of weeks, and we notice that, for example, the engagement rate in our comment section is very low. People don't read the comments, people don't reply to them, etc. And to boost this engagement, we decide to add an upvote system just to make things more interesting. And we'll do that by simply adding an upvote entity, which is going to have its own ID, a link to comment, and a link to author. So let me do just that. Sorry. We're going to create a new entity called upvote. Okay, there we go. We need to add an ID. We'll use a quick fix for that. This is going to be sequence generated ID. Okay, and now we need to reference to author and to comment. I'll use the generate menu for that. Entity attribute. Now we need to pick the type, author. Okay. This is going to be a many-to-one relationship, and it's going to be mandatory. Click OK. We see the association is generated. Now we need to add a link to comment. Okay, same thing, many to one, mandatory. Okay, now let's generate integration and run it. I'll do it a bit faster because you've already seen all of it. Output. Okay. Maven. Migrate. There we go. So we shipped this migration, but now we realize that actually we don't need a separate ID for this entity. It can be uniquely identified by author ID and comment ID. And we want to keep our data model as clean as possible. So what do? Well, we might introduce a composite key, right? Author ID, comment ID. On JPA side, it's very easy to do. First, we delete the old ID. We don't need it. Then we need to create an embeddable, which is going to be a Java class. Let's call it upvote ID. Okay, I've actually prepared it in advance just to shave off a couple of seconds. There we go. So basically we have a composite ID that has attribute author ID and comment ID. Now we go into our upvote and we add this embedded ID using JPA palette. We have attributes, embedded ID. We choose the type. Okay, okay, there we go. Now, the only thing left to change is that we need to replace join column with maps ID annotation. Which basically lets Hibernate know that you need to use this attribute from ID to map this association. So yeah, do the same for comment, maps ID. And notice we need to provide the Java attribute name, not the database name, because that would be using underscore, something like that. And well, it doesn't recognize it because we use the Java naming here. Okay, now, making these changes from the JPA side was pretty easy. But now, how do we remove a primary key from the table? You could just drop the column, right? But there could be other foreign key constraints, for example, that reference this column. So simply removing it wouldn't work. You would have to go through each table, see if there are any reference to this table, which if you have a huge data model, well, might take a lot of time, you might miss something, etc. You could write a script that could do that. Maybe some SQL gurus out there can find it an easy task. I know I wouldn't be able to write it like off the cuff. I would have to Google a lot because, well, I'm primarily a Java developer and not a DBA. So yeah. And again, if we simply generate the script, we'll see that drop primary key is generated as such, which is basically the script I was talking about. So JPA Buddy has written it for us, and we don't have to deal with it. Imagine having to write it by hand each time. I can't. So yeah, let's name that change, update ID. Okay. Now, as our application, actually this was the third challenge. Not everything we create is easy to drop. Primary key is an example that we looked at. I know about default values in MS SQL. There's basically no drop default value statement there for some reason. And solution is migration script generation. Now, as our application evolves, we might want to ship it to other environments, and we might have different RDBMSs there. For example, we were developing using Postgres, but what if we had to deploy this application in an environment where only MySQL is available or something like that, or just someone wants to run it locally and they prefer MySQL over Postgres or something like that. Now, why supporting several RDBMSs is a challenge in the first place? Each of them have their own slightly different syntax, a different type system, and different available operations. As I mentioned, there is no drop default value in MSSQL, as an example. So you basically need to have migration scripts for each RDBMS, individual migration scripts. Now, if you have code generation, this isn't much of a problem. You just click New, version migration. You simply select another connection. Here I have an empty MySQL database. If I run the generator against it, I get the whole script here that initializes the data model as it is. So yeah, and then when we start to develop the application further, we can basically generate these scripts in parallel for each change that we make. So yeah, much easier than writing them by hand. And well, another thing to keep in mind is that migrations take time to run. I know it sounds obvious, but some developers miss it. They basically test their migrations locally. They run almost instantaneously. And once they ship it to prod, that's when we start to get some problems. Examples of changes that take time is, well, obviously index creation is a big one. Usually you have like a small test data set on your local machine. So index creation is very quick, but if you run it on like millions of records, well, that's where you get a lot of execution time, and it might lock your database or your table, which will hurt your performance. And even things like table renames might lock the whole table, which can cause availability problems in prod, which a general advice here is to always test migrations on prod-sized keys. Well, at least if you have like these potentially long operations like index creation. I know it's not always possible to have access to, for example, a copy of the prod DB, but at least you should strive to create similar sized test databases that you can test your scripts against. And for indexes, actually, there's another solution, which is called hypothetical indexes. Not all RDBMS is supported, but Postgres does. Basically, it's a tool that lets you estimate in advance the impact of having a particular indexes, whether it's going to benefit your performance and how much space it's going to take up, etc. So that's a very useful tool to plan your indexes in advance before you actually ship them to prod. Yeah. So I've been advocating code generation a lot in this talk, you might have noticed, which shouldn't be surprising since we develop a tool that primarily deals with code generation. And I know it's not a silver bullet. There will always be cases where you have to implement something manually, or you always have to review the generated code before you actually ship it. Because, well, you can't always trust the tools 100%. People who develop them are also people, they make mistakes. But still, I do truly believe that code generation can save a lot of time and a lot of effort. So yeah, please use it. Anyway, that's been it. Please follow JPA Buddy on Twitter, and you can also follow me if you want to. We post a lot of useful materials on JPA DB stuff in general, Flyway, etc. We also showcase a lot of JPA Buddy features, which is, well, our Twitter is like the best place to start learning about our products. So yeah, and if you have any questions, I'll be happy to answer now, or you can contact us via Twitter. We're always happy to chat. Yeah. So, Barry, do we have any questions in chat?
Yeah, no, thank you, Andre. Yeah, just to remind everyone that we also have a Q&A box if you want to leave any other questions. We do have a couple of questions already come in. First of all, one dealing with, you mentioned before about different database usages with JPA Buddy. Obviously, there's differences between Java typing and database typing. Does JPA do anything automatic around mapping those types, those Java types to database types, and about customization of which ones you can use?
Yeah, we do basically have a dictionary of which Java type matches which SQL type, but for some cases where the user wants to have it customized, we actually have a separate section in our plugin settings. You just go to JPA Buddy, database versioning, type mappings, where you can manually create some mappings, for example, from string to, well, let's make it simple, varchar, and we define length, and that's it. So moreover, you can have like separate type mappings for each RDBMS that you're going to use. Right now we support 6, which is MySQL, MariaDB, Postgres, MySQL, etc. So yeah, if you run against both Postgres and MySQL, you can have separate mappings for each of them, which I think is neat.
I hope that's answered that question. In addition to that, another question this is to do with, well, Flyway and JPA Buddy's interactions. For someone who is already using Flyway, we see that your code generates the scripts, the version numbers. Is that something that, if you were migrating over to JPA Buddy to carry on using your Flyway for our Flyway customers, how easy is it those generated scripts to be sort of added on to the additional ones they've already got? So like version.
Yeah, I get it. So basically, it simply looks through the folder that you have configured where you have the scripts. It finds the largest version number, and whenever you generate a script, it basically increments that. So this could be a fresh project. JPA Buddy might know nothing about it, and it will generate the correct number. Moreover, if you have like a different naming convention that you use, we actually do have it in settings. You can customize that as well. So whichever pattern you use, we do provide some values here for the version pattern. Maybe you use another migration separator, maybe you use like some standard description, maybe all your descriptions start with a ticket number or something. So you might add that in. So yeah, basically it's configurable and it detects what's the biggest version that you have right now, and it implements it in the next script. So yeah. Does that answer the question?
Okay. Yeah, I think it does. Just checking through if we've got any others in yet. No, that looks like that's the only ones in at the moment. Hopefully we'll receive some via our other channels after the seminar.
Sure. Yeah. Okay. If anyone has any questions, again, would be happy to chat on Twitter. We also have a Discord channel, which you might find via our website. So if you go to jpabuddy.com, we have all the links here to our Discord, to our Twitter, YouTube channel, etc. So we're always happy to chat because our product is mainly community driven. So most of the features that we implement now are features that people request. So yeah, if you have any ideas, any bug reports, etc., we'd love to hear them. That's what we have those channels for.